Hi there, so in this video we want to talk about polynomials in several variables. So that just means there's going to be more than one variable in our expressions. The good news is there's not anything really new to go over. It's just adding some complexity to this. And if you just want an example, so we might see something like 3x to the fourth times y to the second minus 2x squared plus 5y squared. Okay, so something like that, and then we'll have to do our operations on them: add, subtract, multiply, and divide. Okay, and so there's nothing new if you've been through all the videos that I've put in, and the key thing is to understand two key things here, the two key concepts that we've talked about. Okay, the first one is this idea of what makes something a like term, or what constitutes like terms. Okay, and these are terms that have the same variables to the same powers. Okay, like that. All right, so for example, like that, I could have 4x squared y to the third and 8x squared y to the third. Those are like terms. Okay, why are they like terms? Because we have the same variables, x and y in both of them. I didn't write that second exponent very well there. Okay, and then also x is to the second power in this one, and x is also to the second power in this one. Y is to the third power here, y is to the third power. Okay, but let me just show you the distinction so you can see what I'm getting at. Is I could have 4x squared and 8x squared y to the third. Those are not, okay, like terms. All right, why are they? They don't have the same variables. The first one only has x squared. The second one has x and y. Okay, and also 4x squared and 8y to the third. Those are clearly not, okay, like that. But I could have something like 4x squared y to the third and 8 x to the third y squared. Okay, now you might be saying, yeah, they have the same variables and the same exponents. There's a 2 and a 3 here, there's a 2 and a 3 here, but notice on this one they're on different variables. So in terms of the variable part, you ignore the coefficients whenever you're identifying like terms. But in terms of things being like terms, the variable part should be identical in both of them. So see, those aren't identical. Whereas right here, the variable part of these are identical to each other. All right, and so that's what constitutes like terms. So let's look at those two, the idea of collecting like terms with an addition and subtraction problem. Okay, so here we have one polynomial and another polynomial. The key thing is to notice the operation that we're doing. We're just adding. Okay, whenever you're adding, if you remember, you can just drop the parentheses. All right, and then if there's any like terms, you collect like terms. Okay, oops, forgot to say like. So we collect like terms. Okay, like that. And so all we really have here is we have x squared y squared minus x squared y plus xy squared plus y plus 3x squared y minus 5y. All right, now the way I do this, it's up to you how you want to do it, but what I do is I just take that first term, the x squared y squared, and then I look through my polynomial and see if there's any like terms for that. So to be a like term, it has to explicitly have x squared y squared in it, but there's not one, so that doesn't have any like terms. So now I just go to the next term in my polynomial, and sometimes it helps to scratch out what you've already worked with, so you to make sure to cover everything. Okay, and so my next term is minus x squared y, like that, and you look through, are there any other x squared y terms in this polynomial? Right there is one. Okay, so this is just the way I do it, and so then I write plus 3x squared y. Now I'll cross out those two terms that I've covered. So then I just go to my next one, and I have plus xy squared, like that. We look to see if there's any xy squared terms in here, and there's not, and so I can take that one out. And then my next term is plus y, and notice the only other term is minus 5y, but those are actually like terms too. And see, by crossing out, I make sure that I didn't skip over any terms, that everything's still there. They're just written in a different order. Okay, so now I just got to collect my like terms together. So there wasn't one for the x squared, y squared. Okay, but here we do have a pair of like terms right here. And so remember, to collect like terms, the variable part stays the same. So I'm still going to have x squared y. And then I just operate on the coefficients. Remember, if a coefficient's not written, then there's a 1 there. So really we have minus 1 plus 3, and that is plus 2. So we get plus 2x squared y. All right, and then I just proceed over to the right. Xy squared has no like term, so it stays here. And then here I have y and minus 5y, or plus 1y and minus 5y. So again, whenever you're collecting like terms, the variable part stays the same. And then I just operate on the coefficients. I do 1 minus 5, which is minus 4. And that would be the answer to that problem right there. So you can see there's nothing new. It's just more complicated and more things to keep an eye out for. Okay, so now in the second example, what's our operation? We're subtracting. So if you remember that advice, I really like that advice that I had in my video. Whenever we subtract, you change the minus to a plus. But remember, basically we're distributing a -1 whenever we do that. And so, but the only effect of that is to change the sign of all terms in the second. While I'm doing that, I'll point out something. Math has a lot of very interesting vocabulary in it that's a little obscure. People don't use very much. But the thing that you're subtracting, anytime, not just with polynomials, but whatever you're subtracting, that thing's called the subtrahend. And so instead of saying in the second, we could say change the sign of all terms in the subtrahend. I'm sure that's really valuable knowledge to you. Okay, great word though. Anyway, so what I'm getting at here is, first I'm just going to rewrite this as an addition problem. So you don't mess with the first term. If you want to go ahead and drop the parentheses, you can. But, oops, 3y to the fourth, like that. So I changed that minus to a plus. You see what I did there? I just changed that minus to a plus. Okay, but then keep your parentheses at first. And so now I'm going to change the sign of everything in the second one, or in the subtrahend. So we got minus 2x to the fourth minus 3y to the fourth. Okay, see, and now the point is, I'm just doing an addition problem. It's just like this last one. I can now drop the parentheses. Okay, and so I get x to the fourth minus 2x squared y squared plus 3y to the fourth. Now, you can shortcut this next part, but let's just, since I said just to drop the parentheses, so we get plus, but then we have minus 2x to the fourth minus 3y to the fourth. Okay, like that. All right, and just remember, I have this plus and minus right here, so that's just going to become a minus. All right. So anyway, now we're just collecting like terms. So just like with that last problem there, it kind of bugs me because I'm going to be scratching stuff out up here. So just remember that this part right here is going to become a minus whenever I rewrite it. All right, so remember what we did last time. Oops. I take my first term, x to the fourth, and then I look through and see if there's any, oh, right here, there's an x to the fourth term. And so remember, I can write that plus a negative as minus 2x to the fourth. Okay, and then I would scratch those out to remind me that I've accounted for them. And then the next term down the line is minus 2x squared y squared. And I look to see if there's any other x squared y terms in here, but there's not. Okay, and so I can scratch that one out. And then lastly, I have this plus 3y to the fourth and minus 3y to the fourth, like that. Okay, and those, so see, everything's scratched out, so I know I accounted for everything. All right, and so now we're collecting like terms. x to the fourth minus 2x to the fourth. That's x to the fourth. Remember, collecting like terms, you don't change the variable part. And we just operate on the exponents. So that's 1 minus 2, which is negative 1. Okay, and then the second part right here doesn't have a like term, so it's minus 2x squared y squared. Okay, this part's interesting. Here, if you want to write, I'm going to need another line anyway. So we get plus, collecting like terms, the variable part stays the same, but then I do 3 minus 3. 3 minus 3 is 0. Okay, so you just got to remember 0 times anything is 0. So 0 times y to the fourth, that equals 0. So that part, this whole part right here becomes 0. And if we're adding 0, we usually don't write it. So the way we would write this answer, you could keep the negative 1 in front of the x to the fourth, but just general practice is if your coefficient is a 1, we don't write it. So most people would write this answer as negative x to the fourth minus 2x squared y squared. That's the way we would write that answer. The second basic concept to remember is the first exponent law 1. And it says that a to the m times a to the n is a to the m plus n, i.e. if we're multiplying two things with the same base, we add the exponents. But that's very important. Be careful with that, is that these two things right here, you have to have the same base. Okay? So, we've seen this already. If I have x to the fourth times x squared, those have the same base, so I can add the exponents. Okay? But if I have x to the fourth times y to the second, those don't have the same base. And so that doesn't equal something like xy to the sixth or something like that. Just doesn't make sense. So if they have different bases, you just don't mess with them. Okay, and so like that. Now what this is going to tie into is multiplying monomials that have several variables. Okay, and so this is where this law and this concept will come into play. So say I have something like 2x squared y to the fourth, but then I want to multiply that by 5x to the sixth y to the third, like that. Okay, so these are two monomials. Remember, the idea of multiplying two monomials is you can do it in your head once you get used to it, but the idea is that since you're just doing a bunch of multiplications, the order doesn't matter, so you can group together the numbers. Now what's different is we need things to have the same base, so I want to group together the x's, and then I want to group together the y's. Okay, like that. All right, and so now 2 times 5 is 10. And so here we have two things with the same base. I can add those exponents. Okay, and then here I have two things with the same base. So I can add those exponents, but I can't combine these two things in any way. All right, and so that would be the answer to that problem. Okay, and so that just leads into multiplying. The thing is, it's exactly the same. And what do I mean by that is that basically we just distribute, okay? And then we just got to remember that concept. To add exponents, we need things to have the same base. And so just some quick examples here. Say I have 2x squared y, and I want to multiply that by x squared minus 4x y plus y squared, like that. So here I have a monomial. This is a monomial times a polynomial. And so what do we need to do? We need to distribute that 2x squared y over that entire polynomial right there. And so to do that, you can write it out to help you. Some people can do it in their head. Just be careful if you do that. And then minus 2x squared y times 4xy, and then plus 2x squared y times y squared. Okay, like that. And if you need to, like I say, you put in as many lines as you need. I just want you getting them right. Okay, and so if you need to, group together your variables, the common variables. Okay, oops, sorry. Started moving too fast. So on this first one, there was no number to multiply the 2 by. But here we have a 4 times a 2, so we could say minus 8. And then if you need to, you can group together your x's and group together your y's. okay? And then plus, on this last one, there's nothing to multiply the 2 by. And then there's just the x squared term, and then we have y times y squared. I'm not sure if you need that line right there, but just in case. All right, and so here we have a 2. Here we have two things with the same base, so I add the exponents, but there's only one y part to that term. All right, and then we have minus 8. Here we have two things with the same base. Remember, if the exponent's not written, it's a 1. So we get x to the third. Same thing with these y's. So that would be y squared. All right, and then plus 2x squared. And so remember that exponent is 1. So we have 1 plus 2. We'll get y to the third. And then that would, remember at the end, if you're just distributing one thing, this won't happen. But just try to get it in your mind so you're always doing it. Try to look for like terms at the end. There aren't any like terms here. And so be careful on these last two. Why did they not combine? We do have an x and a y, but x is to the third here, and x is only to the second power there. Each variable has to have the exact same power to be like terms. Okay? And then we could, let's say we have 2xy minus y squared times 3xy plus x squared. Like that. Okay, so now we have a polynomial times a polynomial. You could think about using the FOIL method here. Like I say, I don't like thinking in terms of FOIL. What do I like to think in terms of? Distribution. So I'm going to distribute this 2xy first over those two terms. So we have 2xy times 3xy, and then plus 2xy times x squared, right? And now be careful on this second one. What are we distributing? We're distributing negative y squared over each one of those. Okay, and so think about that as being a negative 1. So we have negative 3 y squared times xy, like that. And then we have minus y squared times x squared. Okay, so now we're ready to start simplifying here. So 3 times 2 is 6. And then notice we're going to have x times x. If you think exponent law, that's x to the first times x to the first. So that's going to be x squared. Or just remember, x times x means x squared. All right, and then also we have y times y, so that's y squared. And then we get plus 2 times, this is x to the first, so we get x to the third because I did 1 plus 2. I don't know if that was clear right there. And then that y is only to the first power. It's not multiplied by any other y. All right, and then we have minus 3. We just have an x. And then y squared times y, that's y to the third, like that. This last term you could keep it written as it is, but typically we write them in alphabetical order. All right, and now we need to look for any like terms. Here's an x squared y squared. Oh, we do have like terms right here and right here. Okay, and so you could take another line to rewrite this over here like that, or I'm just going to get straight to the answer here. So remember, if you have like terms, I know I keep saying it, but I hope I'm very repetitive where it gets glued into your brain, that whenever you're collecting like terms, the variable part stays the same, and we just operate on the coefficients. And so that's 5x squared y squared. All right, and so there's a pair of like terms we just took care of, and then there's no like term to this, and there's no like term to that. So we are at the answer. Oops. So we have plus 2x to the third y minus 3x y to the third. Okay, and that would be the answer. All right, we'll do one more example, mostly just to remind you about how to square a polynomial. So notice that I am squaring right here. Okay, and so remember what it means to square something. You multiply it by itself. Okay, so we have 2x squared y plus y to the third times 2x squared y plus y to the third. All right, and so just like with the last example, first we're going to distribute this one. All right, and then we're going to distribute this one. Okay, all right, so we're ready to go with that 2x squared y. So we have 2x squared y times 2x squared y. All right, and then plus 2x squared y times y to the third. All right, so you see what I did? I just did these two distributions right here. Okay, and then, so now I'm ready to distribute the y to the third over these two terms. So then I have plus y to the third times 2x squared y plus y to the third times y to the third. All right, we're almost there. And so we just keep trucking along here. First we do this multiplication. So we have 4. Remember we add the exponents, so we get x to the fourth, y to the second, because remember again, those exponents are 1, so we have 1 plus 1. And then plus, now we're at this second part, this second term. We just have a 2, an x squared, and then y to the fourth. Okay, again, I know I'm being repetitive, but remember that means y to the first. All right, and then here for our number we have a 2, and then there's only an x squared, but we have y to the third times y to the first, which would be y to the fourth. Okay, and then plus, our last term only has y's in it. 3 plus 3 is 6. Okay, so what do? We look for like terms, and I kind of went against what I was saying when I was adding. So I write the first term, and then I look for any like terms to it. So I would need an x to the fourth y squared in here, but I don't have that. Notice I have x squared y to the fourth, just the opposites, but those aren't like terms because x is to different powers. Okay, and so we've taken care of that one. And so then I just go to the next one down the line. So 2x squared y to the fourth. And then notice the one immediately to its right is also a like term. Okay, and so we get those. Some of you may not need this line also. And then we have plus y to the sixth. That takes care of the last term. All right, and the key thing is, these are like terms right here. And so I need to get those added together. But let's first write the first term. 4x to the fourth y squared. Okay, so again, remember, once you're collecting like terms, the variable part stays the same, and then you just work with the coefficients, and that's a 2 plus a 2, so we get 4 there, and then we just have plus y to the sixth, and that is the answer. Okay, hope that makes sense. Make sure you realize if you've been through the videos and been practicing, there's nothing really new here. It's just being careful about what constitutes like terms, and then remembering the only way you can add exponents is if you have the same base, but everything else is the same as one variable. All right, I hope that helps. Good luck.